Hello guys. So today's topic is mechanical work and energy. So work, potential energy, kinetic energy and strain energy. We have seen that we gain an insight into the forces and stresses involved in the biochemical systems by using equations static equilibrium alone. However, if we study or involve in dynamic actions such as running, jumping, we shall need to develop an additional techniques. One of the most powerful tools available to us is the principle of conservation of energy, which means energy neither can be created nor can be destroyed. So, energy is a scalar quantity. We know that there is two quantities, scalar and vector. Scalar is only numbers, and in vector there should be a coordinates also. So, energy is a scalar quantity with the units SI unit of joules. Joules are derived units equivalent to the Newton meter. We should not confuse energy with moment or torque, which are vector quantities. As I said, vector quantities have magnitudes and as well also the direction also, which is measured by the Newton meters. The concept of work is similar to the energy. We usually associate energy with the body and the work with the force. In this chapter, we shall concern ourselves only in the mechanical energy and not with other forms such as heat energy. So, the work done by a constant force acting on a body is equal to the force multiplied by the distance moved in the direction of the force. If the force and distance moved are taken to be vectors, then the work done are the dot product by the definition. Therefore, the force and the distance moved are taken to be vectors, there is no displacement and there is no work. In the conservative system, all of the work is done to the body is recoverable from it. In some sense, it is stored within the body in the form of energy. And second one is the potential energy. What is the potential energy? It is associated with the potential of the body to do the work against the action of the force. In order to body you have a potential energy, it must be objected into the force field. Potential energy can perhaps best understood by considering the work done by the force acting on the body. The work done by the force equal to the potential energy lost by the body. The weight of mass in a gravity is mg, which is weight is a force. In order to lift a mass slowly from one star to another, we would have to do a work. This work could, however, we can recover by if we allowed the body to fall back to the lower step. The work would be done by the gravitational force during the process, falling more potential to do work or potential energy. When it has top step relative and it is a bottom step, obviously we can choose the position, reference position, and the potential energy can be relative quantity. And there is a kinetic energy which is associated with the motion of the body. Newton's second law states that for a particular constant, force will accelerate a body in the constant rate. The work done by the force is the body converted into kinetic energy of the body. The kinetic energy K of a body of mass m travel at the velocity v is equal to k is equal to half mv square. And another one is the strain energy. It is associated with the deformable body which have elastic property. If the deformation is elastic, then all of the strain energy is recoverable if we load removed. The strain energy in the bar can be defined in the terms of area under displacement curve. Once again, the energy of body can be calculated from the work done by the force acting on it. In this case, the force is not constant but applied gradually. So the particular value for the force is associated only with the increment of displacement. Using the above definitions, the potential energy and the kinetic energy, the terms we use studying in the dynamic of rigid particles. For deformable bodies, we have strain energy, potential energy, and as well as kinetic energy. But by the law of conservation of the energy neither be created nor be destroyed, but there is some peculiarities, some modification which is non-conservative energy, which means in the deformable body when we reach maximum elastic capacity, the body will break. So we can't recover the energy we have used to it. If we want to create the original body, we have to use more energy. And second one is the how we use principle applied to the conservation of energy. So in the falling and jumping, we know that we can extend the principle, estimate the forces applied following the jumping action. Consider, for example, a case a person is dropping the wall on the ground level. He is jumping. There is a 3-stage energy. When he was standing, there should be a potential energy. And when he start to jump, there is a free fall, which means the potential energy is converting into the kinetic energy. And when he lands in the bottom of the ground, when he bends his knee, which is strain energy, that means there are 3 energies are working on his body. So we can apply the principle of conversion of energy of all time, which will fall commence to the at which rested the body in against stationary. At the both times there is a kinetic energy is 0, and there is the force potential energy converted into strain energy, then it is converted into potential energy. The second problem is landing on a bended knee. It is addressed as the method adapted could preferably and reliable results to the first problem, because of the difficulty is estimating a dynamic impression of the skeleton. An alternative approach would be take legs as a spring, which is a comprehensive force being proportional to its displacement to acute strain energy in the legs and the ending of elastic process which potentially energy lost to the body. So that's all about the conversion of energy, kinetic energy, potential energy and strain energy. Thank you.